Welcome to the unit on key terminologies. In this unit, you will review key terms and definition of apparel manufacturing industry. The final review section invites you to reflect on what you have learned. By the end of this unit, students will be able to understand the key terminologies used in apparel manufacturing, develop suitable methods of managing WIP efficiently, recall ways to make a capacity study. Let's begin to reviewing certain key terms used in apparel manufacturing. Production refers to output. Productivity is the ratio of output to input and is normally represented as productivity is equal to output divided by input. Input refers to all resources used in producing the output. Output refers to goods or services produced. Competitiveness of any location for running a garment manufacturing factory and or exporting units demand various requirements such as availability of labor, raw material, business friendly atmosphere, low wages, proximity to airport and seaport, and the cost of energy. As India is a vast country, the payment system is salary based, piece rate or incentive system. Indian exporters still pay more attention to quantity than quality, though much money is lost due to poor product quality every day. Indian exporters mostly prefer the piece rate system. Piece rate employees are highly motivated. They also have no obligation about their employer. When factories have no work, they don't have to pay operators. There are few challenges when company hires piece rate employees. Designing a fair rate is a major challenge. Most of the factories do not have a system to establish a fair rate or standard time. Generally, rates are decided by negotiations between the employee and employer. Until a rate is fixed, nobody works at their normal pace, and this results in company losing capacity. Let us now look at some more definitions. The time available to an operator to doing work during the day, it does not include lunch time. Time duration which an operator is unable to do some work due to factors which are not under his control, that is the time spent during the day during which no productive work is done. For example, power failure, machine breakdown or doing repairs for someone else. The time made available to operator for producing productive work, it can also be defined as the difference between clock time and off standard time. Thus, clock time is equal to on standard time plus off standard time. Off standard time is that time or the operator spends on unmeasured work or measured work that is classified as off standard. Example of off standard time are time that should be reported on labor cost control sheet, waiting for work, machine breakdown, unmeasured work operation not yet allocated, single minute value. Sampling, repairs not own, paid average for balancing, under retraining, indirect work such as covering for supervisor. Standard allowed minutes SAM also means time in minutes that is assigned to a specific operation after doing time study or using predetermined motion time systems. While single minute value SMV means the cost factor in cost per unit that is multiplied with standard allowed minutes to get the cost of the operation. Standard allowed minute or single minute value is generally calculated as observed time, what has done during the time study, plus rating, allowances, plus personal fatigue and delay allowances, and synthetic time. When standard allowed minutes is used as an extension of single minute value, that is, it is the allocated time for a task rather than the measured time. Standard allowed minutes is equal to single minute value plus policy allowances. Allowances are added to the 100% time determined by the time study to give a standard allowed time. This permits the average operator to earn a satisfactory wage provided there are no abnormal delays. The operator applies herself to her work. Three categories are recognized as machine delay, personal and fatigue delay, and incentive. Machine delay includes the following: thread change, bobbin changes on lockstick machine, cleaning and oiling of the machine, thread break caused by the operator, machine and thread, needle break, minor adjustment or changes in folders and attachments, and first 15 minutes of the machine delay. The machine delay factor is applied to total cycle time. This has the effect of giving a delay allowance on manipulating elements within the machine cycle, such as pickup garment. On an average, this does not present a problem since the percentage has been developed from actual experience. However, a job with an unusually high or low percentage of pure work in the cycle would merit a discretionary adjustment to the factor, and the engineer is expected to be alert for this. Some aspects of normal acquired personal time can be quantified, but fatigue itself cannot be measured. It is also impossible to separate personal and fatigue time because of their interrelations with one another. These allowances come into being through guesswork and trial based on general use. History and experience has proven these allowances to be reasonable, correct for a great many varying situations. Personal and fatigue allowance covers break periods, personal needs such as water and restroom, minor conversations, factors for losing pace due to getting tired. Efficiency is a measure of how well the section or factory is run. It is a measure of both the operator and the supervisor. Incorporates elements of operator performance and utilization into the single measure. When we make a capacity study on an operator, we are measuring the performance she should retain if she continues to work at same pace and use the same method, which can be as observed during the study. This means that at the end of the study, we can say that the operator has the capacity to be 120% performer or whatever performance level the study indicates. Capacity means the same as a capability. It means that the operator is capable of achieving the performance measured by the study. The rate corresponding to the average rate at which an operator will naturally work at a job, provided they know and adhere to the specified method, and provided they are motivated to apply themselves to their work. British standard provide the 0 to 100 scale for rating. Here 0 represents no work at all, 100 as a normal rate. We rate the job on this scale after observing the operator. A slow rate may be rated around 50 and a fast on 125 around. The concept of rating, known as US as grading, is fundamental in time study. The ability to rate effectively distinguishes a qualified time study practitioner from a novice. Rating is a process used by industrial engineering to compare the actual performance of the operator with his or her mental concept of normal performance. In order to rate these must be a defined level of performance to compare with an average level. The rating is numerical value used to denote the rate of working. In order to rate, there must be a defined level of performance to compare with an average level. Time study professionals apply the concept of a standard operator. A standard operator is fully trained and motivated to perform a defined task having a defined method and is by definition average in terms of his and her work pace. Standard performance is achieved by a standard operator as long as working conditions are correct. Operator performance is primarily a measure of effectiveness of individual operator, sometimes referred as a pay performance as it is usually measured within an incentive scheme. Operator utilization is a measure of how well the supervisor manages to keep the operators on standard. That is time on standard divided by the time attended, that is clock time into 100. Let us know how at some more definitions. Standard allowed minute, the time taken by a 100% normal operator to do a particular operation, including the personal, fatigue and delay allowances. The standard time produced by an operator in a particular day, it is calculated as standard allowed minute produced is equal to number of pieces produced into standard allowed minute for the operation. The work done by an operator during the time available to him in a day, it is represented as efficiency is equal to standard allowed minute produced divided by clock time multiplied by 100. A tool used to quantify the work content of an operator during the day. It is represented as performance. Performance is equal to standard allowed minute produced divided by on standard time into 100. A tool used to determine the time percentage during which the operator worked in a day. It is represented as utilization is equal to on standard time divided by clock time into 100. A line is defined as a group of operators under the control of one production supervisor. Therefore, line balancing is concerned with the operations and work level within a line. It is a function of work study office to provide management with information to help the efficient and productive running of the factory. The part of this information is the process known as line balancing. The method of line balancing will vary from factory to factory and depends on the type of garments manufactured. But in any instance, line balancing concerns itself with two distinct applications. They are setting up a line and running a line. Work in progress, also known as WIP, is made up of all garments and their parts that are not completely finished. For example, a bundle of shirts that has everything attached but has no bottom hem. We can measure work in progress in units or in units of time. For example, if you know what an operation X takes 0.5 minutes per minute to process and we have 5 bundles of 12 units each, then we have 30 minutes of WIP for that operation. That is 5 into 12 into 0.5. In some factory, you can find some operations that have days on inventory waiting for processed. This is unacceptable for many reasons. There are two cost areas that can be reduced if work in progress is controlled. That is investment in inventory. Second one is ability to reduce the production cycle. Inventory is money invested in raw materials when we don't move the goods through the plant quickly, we are affecting cash flow directly. By having low inventory between operations, garments usually have less waiting time and go through the production cycle in less time. Large inventory levels between operations keeps goods waiting longer to be processed. This increases the overall throughput time. Low throughput time permits better coordination between sales and production. It also permits a quicker turnaround on which improves cash flow. Low cycle time gives manufacturers the ability to handle multiple styles. Clients are looking for manufacturers that can meet production schedule, that can handle multiple styles, and since they want to invest as little as possible in inventory. Manufacturers that can handle low inventory, only factory that work with low WIP with able to sell their services. Work in progress can be managed efficiently, managed in many ways. Production planning requires planning from marketing and sales to determine what will sell and what needs to be produced and when. This provides the basis of determine how many operators and machine will be needed. Trims are buttons, zippers, labels, thread, elastics and so on. A cut should enter the production line only when someone has verified that all the trims needed are available. An updated inventory of trims should be kept. A missing label could halt 12,000 unit which is already cut. Holding the 12,000 unit in inventory is not acceptable and could lead to another problem. Careful consideration should be given to loading the production lines. If more products than can be processed are fed into the line, you will overload the line with work what will just sit stagnant. Even if you load the line based on its capacity, you might find the inventory accumulating due to an unbalanced production. Absenteeism and turnover can greatly affect the line's balance. A change in style and bad cutting are other two factors that can put a line off balance. To keep a line balanced, you need informations on the inventory labels. To help regain balance is an unbalanced situation, you can use utility operators, operator transfers and overtime. In order to keep control over the work in progress and to keep the cycle time low, you need to have cuts go as close as first in, first out as possible. For this reason, strict control must be placed on the tracking the cuts as they flow through the production floor. The formula used to calculate cost per standard allowed minute is garment standard allowed minutes into cost factor, where the cost factor is per minute labor cost to the factory at factory average efficiency. Or simply, instead of cost factor, you can multiply garment standard allowed minute by average labor salary per minute, which represents cost factor calculated at 100% efficiency. Whatever method you use must be clear to everyone. Persons who see the report within the factory, cost per standard allowed minute is fixed for a style. Cost factor is equal to labor wages per day divided by shift minutes into efficiency. For example, for a factory shift time of 480 minutes, a daily operator wages is rupees 200 rupee. So if the factory run at 50% efficiency, the cost factor for the factory will be 0.833. In this unit, you have reviewed key terms, definitions and formulas used in apparel manufacturing industry, including production and productivity, line balancing, WIP management, the concept of an on standard, op standard and clock time, SAM and SMVs, allowances, efficiency, capacity study, lost time, rating, labor and wages, as well as cost per minute. Thank you very much.